Hello everyone, welcome to Quantum Guruji. So in last video I have asked you about this to design this nanosheet, right? So this is nothing, this is the graphene nanosheet. So I asked you to design this nanosheet of, I don't know how many of you were able to design this nanosheet. So today in this video will be like starting how to design this nanosheet. See, there are two methods to design this nanosheet. First method is, if you know the coordinates of this unit cell, you can simply insert the coordinate and you can get the nanosheet. Okay. Second method is draw from the sketch. Means you don't have anything, you don't have the coordinates, you don't have the angle, you don't have anything. So both method I will be telling you. Okay. So first I will discuss about the case when you know the crystallographic axis. Okay. So suppose you know the crystallographic axis. In that case, what you need to do is go to the build menu, and from there you need to select the crystal, build crystal. Okay. Click here. If you know the symmetry of everything, so you will be knowing the symmetry also. You can put that, you can select that specific symmetry related to graphene nanosheet. Okay. And if you don't know, just book it p1. Now it's the length, edge length. So I'll give 3.21, and the third axis I will keep at 15 angstrom, so that there is no interaction between the layers. Okay, because this is two-dimensional layer, and the angles will be 90, 90 and 120. See, this is the way when you know the coordinates. Okay, so you got this unit cell. Fine. Now we need to place the elements. So in this case, you know the coordinates. So what we can do is we can directly go to this build, add atoms. We need to add carbon, and the coordinates for carbon is 0.333, 0.666, and now we'll go for 0.666, 0.233. So you can see that two elements has been added in the unit cell. I'll go to the display style, and I want it to be in the ball and stick model, specific size. After doing this, what you need to do is uh, you have to go to the connectivity tool. So yeah, from the bond menu you can get the bonds. Yeah, from the bond menu you can go and click on the monitor bonding. Okay, and connectivity. So after selecting everything, calculate. Okay, you need to slightly increase or decrease this parameter so that bond will be shown. Okay, now you can see this bond is shown in this lattice. Okay, after doing this, what you need to do is go here to the find symmetry. Here, find symmetry, click here, give the tolerance value, start with very minimum value. I have told you, right, the difference between, like, what is the difference between these values. So I'll take 0.1 medium, find symmetry. I got P6 mm. What is this? Like that is the symmetry of this hexagonal lattice of graphene nanosheet. Impose symmetry on that. So you got this lattice. Since I want just 2D dimensional sheet, go to the lattice menu. Here you can remove that third dimension, because I have already kept third dimension, like the distance between layers, in a such a way so that there is no interaction. So I'll remove that. So now we have the lattice. Fine. So now we have the graphene lattice. So this is the way when you know the coordinates, you can design the nanosheet. Fine. Now the next step is from the sketch. You don't know anything right now. Okay. So what you need to do is just first design your material or the nanosheet in a CAMDRAW, so that you can easily find the unit cell. Fine. Now you see you have a unit cell, hexagonal unit cell. Fine. And two elements will be there, one here and another will be here. Means at the longest diagonal, two elements will be aligned, right? So you need to align that unit cell, you need to design that unit cell, and you need to keep in that, this hexagon in such a way so that that is lying in the longest diagonal side. Fine. Now what you need to do, make another new 3D optimistic document, Now first you need to make that unit, just that uh, okay. So yeah, we'll go for this, and we'll delete other remaining whatever is not required, we'll delete it, right? We just need two because that unit cell has two elements, right? One more thing I forgot to tell you. Before deleting that, see, we don't know that crystallographic axis also, right? So you have seen here, what is the edge length? Edge length is the, the distance between the center of this hexagon and the center of this hexagon, right? So suppose this hexagon center is here somewhere and this hexagon center is somewhere here, so that will give you, the distance, the edge length, right? So what we can do is click on this atom. Now press control button, again press and click on the other element. Now two elements has been selected simultaneously. Now go, you can see here center, create centroid, right? Just click here, one centroid will be created. Same thing do here, this side, select these two elements, click on centroid, one centroid will be created. So the distance between these centroids will be the edge length, right? So we'll go to this measure distance, find out the distance between these 2 points. So it is telling 2.0 whatever, that is the telling as a bond length, sorry, the edge length. Okay, so we'll make a unit cell with the edge length of 2.1 angstrom. Okay, in that we'll put this unit. Okay, so next what we'll do, we'll go to the 3D atomistic document again, go to the build menu, create this crystal, build crystal. And since in the beginning you don't know the symmetry, okay, no problem, you just go with P1. In the parameters you have seen already 2.1, right? Roughly 2.1. Then the angle, like in the hexagonal nanosheet you already know the angles, right? 90, 90, 120 will be the hexagonal lattice. So you got this lattice, right? Now what you need to do is go back and delete the extra elements. Okay, and see the distance between these two elements is how much? 1.54. But in a graphene nanosheet, the distance between CC is roughly around 1.41, right? So first what we'll do is we'll reduce this bond length. Now it is 1.34, so slightly we'll increase it. Now it is 1.444. It is again huge, so we'll change the parameter from 0.5. Okay, now the distance is 39. It's okay, we'll take this, copy this and paste it here. Okay, and one more thing, while pasting here, be careful, you have to align it. Okay, see, now double click on this CC, only just that fragment will be selected. Now go to this movement menu, and now you have to rotate it and you have to align this. I have already told you, right, in a longer diagonal side, right? Right, now you see that is nicely aligned in a plane. Yeah, that also is very important, you have to align in a plane. Okay, fine, so that is aligned now. Now what you have to do is go to this display style. Now you go to the lattice and there you increase. Now you see, right? Now what you can do is go to the build menu, go to the bonds, again you monitor bonding. See now connectivity, right? Now go to this symmetry option, find symmetry, then you are getting CMMM here, not better symmetry, because we know that symmetry is P6 MMM. Go for the ultra fine, so again you are getting PMMM, only D2, means there is some issues. If this bond length is 1.1, okay, so this bond length is getting shorter and this is also getting shorter. So in that case what we can do is we can increase the lattice parameters. So directly right click, lattice parameters, just instead of 2.2 just give 2.3. now the lattice is relaxed. Okay, now this element, this bond length is 1.53, so just decrease this slightly. Okay, now you go to this find symmetry. Now you got P6 mm, right? So now you got this lattice nicely. Display style again. You don't need third dimension. So see, this is your nano sheet. Okay, so I have shown you the two ways how to design a nano sheet. Similarly, you can work with 3D materials, whatever materials you want to work with. So there are two ways. Okay, first case, if you know the geometry or the coordinates, you can simply insert those coordinates, or you can just, if you have already the structure, you can go to the file menu and you can go open the project, or you can export the image, or sorry, import the image. Okay, or the file, whatever is there. And other way is from the scratch, when you don't have any idea about the coordinates, in those cases we'll be using this. Okay, so in next video we'll be seeing how to do the calculation in CASTEP. Okay, in Metal Studio. Thank you for watching the video.